Okay. BPTU comparisons. As you've seen, my comparisons, they are very important for STP. The first comparison I did is of comparing my bridge IDs. Right. We've compared my bridge IDs. Why? To find the road bridge. So when you compare my bridge IDs, what you're basically doing is comparing information in the BPDU. So this is sort of a summary of all the rules that we have when we are making comparisons. Number one, we compare the bridge IDs to get the root bridge. Number two, we compare the path cost, the road path cost. This one we compare to select at not my road port. So this one is used, let's say this one is used to identify road bridge. Why haven't we defined my route yet? Route, okay, road port, right? We define here, we compare my route path cost to select the not route port, right? Smallest bridge ID of the network bridge. Then we have this one, which will be used to elect yet not the designated ports. Then the last one, smallest PID, is used as a tiebreaker. Usually partnering at the blocked port. Best explained, I think, again in using an example, which I think we're going to get from there. But basically here, these are some of the rules. My comparisons are not. So we compare my BIDs, we compare my RPCs, then we also compare my PIDs. Configuration, BPDU forwarding process. What do we have here? Right. Here we are looking at exchange of configuration BPDUs. So switch one, it sends configuration BPDU RARO. It has information. Most importantly, this information, that's the bridge ID. 4096, 123. 4096 is probably our priority. Let me see. 1, 2, 48. 1, 2, 3, 4. 1, 2, 3, 4, 48, 12. No. That's our MAC address. So here it's not there. Okay, the bridge ID, like we said, I was trying to figure out what is the bridge priority. It's not there. So there's only the MAC address. So information being sent via the BPDU, most importantly, we have the bridge ID. So in this example, if we compare the bridge ID of this one and all the switches here, switch 1, switch 2, switch 3, we will then be able to identify what the root bridge is. I think that's basically what was being explained in the slide here. I'm a bit close to the outer now. But basically, we exchange my BPDUs. Why? So that we can then compare my bridge IDs. So this one, this is BPDU rest switch 1. I can see it. Rest switch 1. I think Raskapa switch 2, Raskapa switch 3. There isn't much here. I can over explain. I don't think there is much there. STP calculation, number 1, select a root bridge. Right, we have simple steps when step number 1, 2, 3, 4. These are the steps you have with STP. These are the steps you need to understand with respect to STP. Number 1, we need to select the root bridge. How do we select that? We compare my bridge IDs. Number 2, we need to select the root port. How do we do that? We compare my RPCs. Number 3, we need to select the designated ports. Designated ports are selected depending on the root port I'm going to choose. Very easy process. We'll take a look at that. And lastly, if you selected Oma port ese, port Rengrasara becomes the blocked port. The alternate port, depending on which type of STP you're using. Alternate port, I think the other one, okay, it has slipped. But basically, that's the blocked port. So those 4 steps, if you understand them, you understand how STP functions. Step number 1, easy. Select a root bridge. How do we do that? Compare BIDs. In this example, let's say my BID is Edu. The bridge priority is the default because I'm not seeing it. The bridge priority Edu is the default. Chandrugona chete MAC address. So let's say it's default 32. Keep this number in mind. So by default, that's the value of bridge priority. If it is the same, I'd go and look at the MAC addresses. My MAC addresses were never the same. I look at the lowest MAC address that we have. So here na A, the lowest here, because ndo pakasiyana apo. ABC. Therefore, this becomes the root bridge. Step number 1, done. If you identify the root bridge, takuenda pa the next step. A little bit on the text here. The switch with the smallest BID becomes the root bridge, done. Only one root bridge exists, done. The role of the root bridge can be preempted. It means it can be changed depending on my changes, my topology changes, and then my network. To ensure stability of the switch, you are advised to plan STP network in advance. Set the bridge priority of the switch that is planned as the root bridge to the minimum. That's a way of manipulating what becomes the root bridge. By default, ASA and a value here. But if you have a switch that you want and you prefer becomes the root bridge, you then go and change the bridge priority. You change it, you get a 0. 0 is the lowest bridge priority we have. Therefore, that switch will become automatically the root bridge. In summary, step number 1, identify the root bridge. Number 2, we identify my root ports. How we identify my root ports? Very easy. So in this example, we have identified root bridge, the irrape. Root port, by definition, is the path in the lowest cost to get to the root bridge. Ndoma forwarding ports edu, am I sure? Right. Ndoma forwarding ports edu. Each non-root bridge selects the root port. Let me see. One root port. A root bridge switch has multiple ports connected. The root port receives the optimal configuration located on each non-root bridge and has the shortest distance away to the root bridge. So the shortest path to get to the root bridge, do yatinoti root port here. So if I take a look at this one, switch 3, kuenda up, do the shortest path here in terms of cost, then kuenda uko. So let's say my cost is their default. Let's say my links here do my 100 megabytes per second. It means cost here do pana, you get 18. Cost here up, you get 18. Cost here up, you get 18. So for me to get from switch 3 to switch 1, it costs me 18. To get from switch 3 to switch 1, which is the root bridge, is going to cost me 36. Kuna lowest kuno port rate iris door network yanan's root port. That's how you identify the root port. So the root port is identifying by using my cost. The guy by switch 2, in door with a root port. Why? Because in door need the lowest cost to get to the root bridge. My root port, excuse me, my root port atopera. Kanone nungo the definition to cost. We are going to realize my ports ese are across root bridge yedu achete my root port. So iri ndo root bridge port iri ne port iri anongoita ma root port. But ukabata uchidaro network ikazoti kurei, it becomes very difficult. What if tikaitika rimwe switch up? Toya tesa rimwe switch up. Toya tesa richilenga ukoko. Ukabata mubatiro, it becomes very difficult for you to see kuti ndikati chaka kuti root port panapa paswitch iri nderipi. It will be difficult kuti closest nderipi between iri neiri. Very opposite, adjacent, whatever the word. So bata the root port by looking at the cost. Kana ndiri panapa kune cost shoma kuti ndisvike panapa ndikupi, ndoenda nekupi, ndo rinoita root port iroro. So root port done. Then identify the designated port. Designated port is that our forwarding port? That's our receiving. That's our receiving port. Designated port, it is very easy once we've identified the root port. Right. After the root port is elected, the NAT root bridge uses optimal BPD use, blah blah blah, received by all ports. If the former is better, the port is designated. If the latter is better, the port is not a designated port. All right. In easy terms, my ports mamwe ese anenga sara. We've identified the root bridge. Excuse me. We've identified my root ports. Ese anenga sara. They become my designated ports, except for one. So esa sara, this one is designated. This one is designated. This one is designated. This one is designated partly. Right. Why partly? Because one of them will become the blocked port. So choosing process to make it easy, what I usually do, identify the root bridge. Okay, identify root bridge, it becomes easy to identify the root ports. Okay, identify my root ports, esa sara, omati ma DP, keeping in mind that one richa change. Ese zvari ma DP, richa change and ripi. We go and compare. We compare my BIDs. So in this example, if I take a look at this one, SR2I, ndotoziva kuti ndo richaita blocked link here, but richaita blocked port in the rip. So SR2I, I take a look at my BIDs and my switch. Kune the lowest, ndo rinoramba riri designated. So kune B kunoko, ndo lowest, that's why raramba riri designated. Kune the highest kunoko, iri ndo richaita blocked port here. So harichazi designated, rakunzi blocked port, or non-designated in this case. We're going to have my examples. Blocked non-designated on a switch port, a port that is neither a root port or a designated port becomes a non-designated port. And this is the last step of our STP operation. Now going into examples. Steps, number 1, you identify root bridge. Number 2, you identify the root ports. Number 3, you identify the designated ports. Number 4, you identify the blocked ports. To identify the root bridge, very simple. You compare my BPDUs. You compare my bridge IDs. My bridge IDs and a bridge priority and a MAC address. By default, bridge priority 32768. If it is the same, which I'm assuming, because the bridge priority is good up my examples here. If it is the same, then we take a look at the MAC address. So if we take a look at the MAC addresses, root bridge redu richaita chi mune munhu 1 iye kudzai Felistas participate. Root bridge redu nderipa. Root bridge redu nderipi? Right, I was saying to identify root bridge, you compare my bridge IDs.
Apa root bridge redu rinenge riri switch 1.
Voila. So switch 1 becomes our root bridge. Why? Because in doing it, the lowest value in MAC address. Once you've identified the root bridge, you then go to look at my root ports. My root ports do not answer every switch. That is a path cost RPC to get to the root bridge, lowest. That is a panap. Kunok is 1,000. Kunok is 1,000 plus 1,000. I think in Doyangeri 19, it should be 4. It should be 4. So Kunok cost yedu. Kunok is cost yedu times 2. Cost ye Kunok. So Kunok is the lowest 2. Therefore, either in Dornetashi root port. kunoku is the same, iriri ndorinoita root port. Kana tadai so ese asara tombo maasaina madp. So iriri idp, iriri idp, iriri idp, then this one also dp. Last step, you identify the blocked port. Blocked port unoona sei pane madp2, pese pane madp2, you can never have two dps because dp receiving port. Ukaita two receiving port, then which one is forwarding? That's a problem. So you can never have two dps. Pakaita two dps, it means link iroro, that's the one that has a blocked port basically. So how do you then identify with it? This is the designated port and this is the blocked port? You use my tiebreakers. So in this example, tiebreaker here is the bridge ID. You take a look at the ID of this switch, you take a look at ID of this switch. The one with the lowest bridge ID becomes the designated port. So the one with the lowest in this example, the E002. It means this DP stays. This one becomes the blocked port. This one becomes the blocked link. That's basically how we make my STP calculations. Another example, bridge ID, lowest MAC address, I think in the inner one. So this is our root bridge. From there, root ports. By default, can I switch pan up? I think it only becomes the root port, not I think. Can I pan up? This one becomes the root port. Can I pan up? Could I? What becomes our root port? Keep in mind, root ports rinotsvagwa nekushandisa RPC. So kana ndiri paswitch 4 kusingadhure kuenda kuroot bridge ndekupi?
I think kuti root port yedu switch to
Yepaswitch 4.
G0. Sorry?
I'm asking for root port yepaswitch 4. Yepaswitch 2 ndaisa kudhara iri apa. Yepaswitch 3 ndaisa iri apa. Ko yepaswitch 4. Yepaswitch 4, what is the root port?
Switch port tinenge takushandisa ina G002.
Why? It's wrong, by the way, but give me the reason why you think to shandisa ina G002. Right, let me assist. So the root port, we find it by using my RPC, root path cost. So kana ndiri panapa, kuti ndisvike panapa, how do I get there? I can go there, I can go there. Cost by default, let's say my 100 megabytes high. It means cost panapa is 19, 19, 19 or 18, depending how for duplex. Right, 1919. So cost ndikaenda nekunoko is 38. Ndikaenda nekunoko is 38. Macost akafanana. Dai ndine case yekuti pamwe panapa haisi 19 i4. It means I would prefer this one because inenge 19 plus 4, that's 23. 23 is much lower than 38. Then I'll go via this one. However, that's not the case. Let me clear this up. So kana tikaita a case where macost edu akafanana. Macost edu, they are the same here. Macost edu kuenda ku root bridge, they are the same, both 38. We use a tiebreaker. Tiebreaker edu, we take a look at my switch are adjacent R2. So I'm ndoda kutsvaga root port panapa, but I take a look at these two switches. Ndotarisa kuti my bridge ID in the lowest in the heap. In the lowest in this case, the E rukui. Therefore, kunoku ndokuchenda root port redu. Kana ma root port, every switch in a one root port, forwarding port. Kana ma switch edu ese ane ma root ports, the next thing takuasaina madp. So maports ese asara akutoita madp, iri dp, iri dp, iri dp, iri idp, iri dp. Problem ndeapo pane two madp apa. Tikaita two madp, it means link iri ndo riri blocked iri. However, one of these two has to become the blocked port or the non-designated port. Non-designated port pa 2 aya ndinoshandisa comparison yemabridge IDs futi. So we realize that my bridge IDs, they are not only useful on identifying the root bridge, but also useful for my tiebreaker. So here I take a look at this, I take a look at this. This one is smaller than 3. Therefore, this one stays as DP. This one becomes the blocked port. Another example. On this one, you're going to see the port breaker, tie breaker, which at the port ID. Let's take a look at this. Right. We want to identify my port rows. Number one, we always start with the root bridge. Root bridge in the E. We have compared these values. Kuno kuna 1, kuno kuna 2. Root bridge tanaro. Root bridge kana tanaro. The next thing, takutsvaga root port. Root port ndinotarisa pa switch iri. Ndiri pa switch 2. RPC. Kune lowest RPC pa 2 maports aya ndekupi. You're going to realize kuti akafanana ma RPCs aya. Let's say by default rino 19, rino 19 as well. Kana asina kuiswa, we just assume kuti akafanana, right? So to get to switch 1 is 19 on this port. To get to switch 1 is 19 on this port, akafanana. So what do we do? Powder a tiebreaker. So tiebreaker yedu, we look at my port IDs. Tiebreaker number 1, actually, we look at the bridge ID. So in terms of my tiebreakers, this is very important. Number 1 tiebreaker is bridge ID. Number 2, takwenda pa port IDs. So in this example, tiebreaker redu bridge ID rashanda kwese. For example, patatsvaga root port panapa. Tatarisa these two BIDs are. Tiebreaker redu varashanda. Why? Because those BIDs are not the same. They are different. In this example, however, tikadoshandisa BID, you're going to realize that BID ratiroshandisa BID report iri, BID report iri, zvese zvinosvitsa switch 1, which has the same BID. So we cannot use the BID as a tiebreaker. We now use the port ID. So the port ID is an identifier specific port. My ports anosiana, my identifier. We start with priority can I the same, then we go to the ID itself. Chinozosiyana, port iri, if you take a look, rakatonzi G001, iri rakanzi G002. In the lowest PID, the E na G001, because it's port number 1. Typical example, unoona maports are fast 01, fast 02, fast 03, 04. If you compare two maports iri ndorino winner, both ndorino lowest port ID. So basically in this case, iri ndori win election, therefore port iri ndori chata root port. Can I identify a root port? The next thing, identify the designated ports. Let me clear this a little bit. So designated port, which one becomes our designated port? Root port anaro. Then for designated port, right, root port per switch here. Therefore, iri designated port. Iri designated port. Iri designated port. You're also going to realize that pese panga tichita zvinezvi. Pa root bridge, maports ari pa root bridge ese ma DP. So root bridge redu, DP, DP. Root bridge redu, DP, DP. Ukona kuti RP pa road bridge, that's a problem. Road bridge, DP. Maports editor maisa ese, problem. You cannot have two DPs on the same link. Therefore, this link is not blocked in STP ready. Blockwa, then what becomes of these two? One is DP, the other one becomes the non-DP. Which one becomes the non-DP? What do I compare? I compare my bridge IDs. So, nika compare bridge ID in E in the lowest, the E E becomes the blocked port, obviously. Ziva, you know that you can never change anything for road bridge. For road bridge, every port is a receiving port. So we had no need to tag a breakup and up. This one always remains DP because the Reaper or bridge. That's how you work with STP. So in summary, what we are basically doing here, we're identifying the root bridge, we're identifying my port rows in STP. There is need for understanding that so that you see what becomes the blocked link. So steps, number one, you identify the root bridge. Number two, you identify the root port. You then go look at the designated port. Then lastly, you find the blocked link. Per blocked link, you have one DP, one non-DP. STP port states. Oh, right. We have a couple of states ports have in STP. Number one, we have the disabled state. This is basically when the port is administratively shut down. Switch rango if. Switch rango if. Switch rango if. At disabled state, it means port area. It's shut down. That's the disabled state. It's not enabled. Port state number one. Then if we enable it, if it is not shut down, it can have one of those states. If a blocking state, that's the one DP is blocking. So the blocking state is basically the loop prevention state of our port. And in terms of my BPD use, it doesn't send or receive. Does it send or receive? It receives, cannot send or receive service data frames. Okay, it doesn't send or receive. Very important, when we're noticing, when we're looking at these things, it's very important to understand if a switch is sending or receiving BPDUs. With the one disabled, it's very easy. Port is not working. Therefore, it doesn't send or receive any BPDUs. With the blocking state, I'm very tempted to say it receives. Actually, it receives. I don't know why it's saying a blocked port cannot send, but listens. Okay. In addition, the blocked port cannot send or receive service data frames. Okay, it listens to BPDUs. The reason why it listens, because if it doesn't listen or if it doesn't receive my BPDUs, in a case where we have a topology change, then there will be no way blocked port changes to an active port, to a forwarding port, because it's not listening. Very important understanding, do we send or receive my frames when we are in a specific state. So when we're in a disabled state, we do send or receive just so if we're in a disabled state, we send, we do not send, we do not receive. When we're in a blocking state, we do not send, but we receive BPDUs. When we're in the listening state, this one we do not send, but we listen to BPDUs. So STP considers the listening state as the root port or a designated port, but the port is still in the STP calculation. In this case, the port can send and receive BPDUs, but cannot send or receive data frames. So here we are sending and receiving BPDUs, but we are not sending any information. Data, the information, our messages, we are not sending them. BPD use, yes. Data frames, no. Learning state, we are learning about MAC addresses. This is where on this stage, this is where we build up the MAC address table basically. And we listen, we send, we receive. However, after receiving service data frames, the port learns the MAC address. So here we are receiving data frames. That's how we learn the MAC addresses. Then the forwarding state, apa takuita send and receive everything now. We send, we receive my BPDUs, we send, we receive my data frames. I think there is need for a table which basically summarizes what every state does. So tikati, how can we summarize this? So tikati BPDUs ndoti data frames, right? So panapa pa disabled BPDUs hapana chinhu, hapana chinhu. We don't send, we don't receive. Pa blocking, let's have send, let's have receive. We send, no, we don't send. Receive, we listen, yes. Panap, pa listening, do we send? Yes, we send. Yes, we send. But kudata, we don't send by listening. Panapa, we don't send as well. At learning state, we send, we receive. Kunok, we are only receiving. So we are only receiving this end per my data frames. Then the last one, I think we tick everything. That's basically a summary of my state. Why it's important? Ndokunopa mvunzo, ladies and gentlemen. Unopiwa estate, mvunzo kwanzi, are we receiving my PPDUs? And you should be able to know, are we receiving my PPDUs? All right, port state transition. Here we basically describe the state transition of any state. Number one, port is initialized or activated, automatically enters the blocking state. So port redo can already disabled. We are in this state. Then when it's activated, automatically run up in the blocking. Then from there it starts listening, learning, then it goes to forwarding. Then from forwarding, in case of topology changes, either port forwarder, it can get shut down. That's why we have 5. Or it get blocked. Panogona paita rimwe link rine much rine RPC values after calculation much more better than the one. Then it can transition to blocking. Forwarding redu, my learning edu can also transition to blocking, as you can see. Listening can also transition to blocking. Then every state can transition kwenda the disable state. State number 5 here is basically shutting down the link. Right. I think with the time that we have, let us end this session with this one. Then we'll have probably another session to complete what is left of this STP. Thank you very much for your time, Madam Kuzai. Thank you very much, everyone who watched this video.